Now we are going to see different types of bodies. There are three types of bodies. First one is elastic body, second one is plastic body, and third one is rigid body. Elastic body. Let's consider a ball. Two forces are applied on the body. What will happen? Body will get compressed. And when forces are removed, body will get original shape. So condition 1, no forces, original shape. Second condition, forces are applied, shape of the body will change. And third condition, that is when forces are removed, body will regain its original shape and size. So elastic body is that body which regains its original shape and size after the removal of external deforming forces. Second, plastic body. Here, this is ball or body. When forces applied on the body, body will get deformed, that is, there is change in shape. And when forces removed, body will not regain its original shape. So condition 1, no forces, original shape. Second, shape changes due to application of external deforming forces. And third condition, that is shape retains after the removal of external forces. So plastic body is that body which does not regains its original shape and size on the removal of external deforming forces. Rigid body. This is body. When forces applied on the body, there is no change in shape. And third condition, when force is removed. So first condition, when there is no force, shape is original. Second condition, when force is applied, shape will not change. And third condition, when force is removed, shape remains as it is. So rigid body is the body which does not change its shape and size on the application of external forces. perfect elastic body means body which regains 100% of its original shape. Second, perfect plastic body, body which retains its shape 100%, that is 0% regaining of shape. And perfect rigid body is the body which does not deform, that is 0% deformation. There is no perfect elastic, perfect plastic or perfect rigid body in actual practice. And elasticity of any body may collapse after certain amount of force, that is elastic limit. After the elastic limit, if we apply force, body comes into plastic condition or plastic region. This is body, and two tensile forces applied on the body. Force F1 and F2 on the second body, force increases, that is F2, and third body, that is force again increases to F3. All the bodies are having the lengths L1, L2 and 3. As force increases, length also increases, that is change in length of the body is directly proportional to amount of applied force, that is delta L directly proportional to force. If we plot this on the graph, that is force against change in length, for F1 there is delta 1, for F2 there is delta 2, and for F3 change in length, that is delta L3. So we can draw this graph. This shows force versus change in length, that is F versus delta L graph. Similarly, we can plot graph of strain versus stress or stress versus strain. We know this is the area of the first body, A2 area of the second, and A3 area of the third body. Stress is force upon area and strain is delta L upon L, that is change in length upon original length. As we know, delta L directly proportional to force, so stress will be directly proportional to strain. So according to Hooke's law, within the elastic limit, stress is directly proportional to strain. Means as stress increases, strain also increases, or vice versa. At constant E, sigma is directly proportional to strain. So this constant is known as E, that is elastic modulus or Young's modulus. As we know, there is no perfect elastic body, that is, nobody is having 100% elasticity. So elastic modulus is a measure of elasticity. Higher elastic modulus means higher stress is induced for same amount of strain. We can see these on the graph. Plot stress versus strain graph. These are the three different materials, having different elastic modulus. So we can see that sigma 1 is higher than sigma 2, higher than sigma 3 for the same amount of strain. Okay, so that means elastic modulus of 1 is higher than elastic modulus of 2 than elastic modulus of 3. Here modulus of rigidity, similar to elastic modulus, there is no body in the world that is 100% rigid. So modulus of rigidity tells us how much rigid body is. So modulus of rigidity is a measure of rigidity. Modulus of rigidity is equal to shear stress upon shear strain. See into diagram. When tangential forces applied on the body will get shear off. This is phi, that is shear strain. Higher phi, that is shear strain, means lower modulus of rigidity. That is high deformation, less rigid. So modulus of rigidity will be infinite if there is zero shear strain, that is no shear strain. This type of body is perfect rigid body. When there is no shear strain, that is no deformation. So G is equal to tau upon phi, that is modulus of rigidity. Next, bulk modulus. Bulk modulus is ratio of direct stress to volumetric strain. Consider a body when direct stresses are acting, body will get deformed. So this shows change in volume of the body due to direct stress. So direct stress is force upon area and volumetric strain is change in volume per unit original volume. Modulus, there are three types of modulus. First one is elastic modulus, second one is shear modulus, also known as modulus of rigidity, and third one is bulk modulus. These all three modulus are the relationship between stress and strain. So all are having the same unit. Modulus, any modulus is stress upon strain. So stress is force upon area, and unit of stress is Newton per mm square, and strain is delta L upon L, that is unitless. So modulus is having unit Newton per mm square. It may have different units, that is Newton per mm square or kilonewton per mm square or kilonewton per meter square. Important convergence. 1 Pascal is equal to 1 Newton per meter square. 1 kilopascal is equal to 10 raised to 3 Pascal, that is 1000 Newton per meter square. 1 megapascal is 10 raised to 6 Pascal, that is equal to 10 raised to 6 Newton per meter square, equal to 1 Newton per mm square. Please remember, these conversions are very important. Let us take Newton, force in Newton. So 1000 Newton is equal to kilonewton, 1000 kilonewton is equal to meganewton, 1000 meganewton is equal to giganewton, and 1000 giganewton is equal to teranewton. Similarly, on the left side, 1 upon 1000 Newton is equal to millinewton, 1 upon 1000 millinewton is equal to micronewton. Similarly, nanonewton, that is 1000 part of micronewton. Change in length or deformation due to axial loading can be found out by following equations. We know that elastic modulus is equal to stress upon strain, and that is equal to sigma upon E. So sigma E is force upon area and strain is delta L upon L. So equation will be delta L is equal to FL upon AE, or E is equal to, that is elastic modulus is equal to FL upon A delta L.